guys, welcome back to this channel. Thank you all for liking and subscribing to the channel, and if you are new here, please like, share and subscribe to the channel as we reach out to more people on exam P problems and exam P concepts. In this session, we would look at solving sample problems for exam P. This session is meant for those who have a good hands-on on concepts in exam P and want problems solved for them. Please stay tuned. Alright guys, welcome back. This question is on basic probability and the use of the set theory. In this question, you are given probability of A union B to be equal to 0.7 and probability of A union B prime to be equal to 0.9, and you are asked to calculate probability of A. Okay, so we go on to solve this problem. Most exam P problems are to be solved in 6 minutes question. So each paper is a 3-hour paper with each question being solved in 6 minutes. There are 10 questions on the paper. Okay, so let's go on to solve the question. Now, I would start from the second value we have in our problem. The probability that A union B, we have A union B complement, can be written as probability of A plus probability of B complement minus probability of A intersection B complement. And we are familiar with this from the fact that if we have any two sets A and B, probability of A union B is the probability of A plus probability of B minus probability of A intersection B. So we have two sets A and B complement, and this works in the same way. Now, you would agree here with me, and when I draw this set here, right, let's consider this as A and this as B, right? B complement is the region I will shade in red. It's everything in red here, and that is B. In any region in red is B complement or B prime, right? Now, A intersection B prime, right, is the set A, right, intersection everything outside the set A. Are we okay? So A, this is set A, right, intersection B prime, right, will be the region here, right, the small region, because this is the set A and it is intersecting with the complement of B. So any part colored gold, right, is what is A intersection B prime, and you all agree with that. So if I have B prime difference A intersection B prime, right, then it is the set B prime, right, taking off anything that belongs to intersection B prime, and we then realize that it is the green region we have here. So that is the green region, right, which is A union B complements, right? So you agree that if I have probability of B complement minus probability of intersection B complement, that gives me probability of A union B complement. And that is right to say. So this here is the same as probability of A minus probability of A union B complement, right? And this I know to be 0.9, right? I also know that probability of A union B complement is probability of, we have this to be probability of A minus 1 minus probability of A union B, and that I know to be 0.7, right? So I have that 0.9 equals probability of A minus 1 minus 0.7, which is 0.3. So I have probability of A minus 0.3. Sorry, this should be plus. I'm very sorry. This should be plus, so plus 0.3. And this implies that we have probability of A to be 0.9 minus 0.3. And that gives us 0.6. So from our question, the answer to our question is answer choice C, which is 0.6. Right. Okay. We move on to solve the next question. All right. This next problem is also on basic probability concepts and the use of the set theory. So this question says that we are given that the probability that a visit to a primary care physician's office results in neither lab work nor referral to a specialist is 35%. We note that down. Of those coming to the PCP's office, 30% are referred to a specialist and 40% required lab work. We are asked to calculate the probability that a visit to a PCP's office results in both lab work and referral to a specialist. So we will need to define some basic events, right? This L should be the event of having, right, lab work done, right? And we let R be the event of referral to a specialist. So these are the two events we have. To help better understand what we are going to do, I would quickly draw a Venn diagram to represent the information we have in the so. This is our sample space. We have L here and R there. So we are told that from the question that if neither lab work nor referral to a specialist is made, we have a probability of 35%. Now, if neither a lab work, right, let me shade the region, neither a lab work nor a referral is made, then we are saying that none of these two are made. So our event will be the region in yellow, which is the region outside the blue and red shades, right? So it is easy to note that if we have the event of not L complement, right, R complement, so neither nor is represented as the complement of L intersection the complement of R, right? So neither nor is this statement, right? And it's the same as L union R, right? Complement from De Morgan's law. So we have that this L complement intersection R complement equals L union R complement, right? So probability of L complement intersection R complement equals probability of L union R all complement. And you would agree with me that this set here, the set we have here, right, is the same as the sample space difference the set L union R. Okay. So let me write this in blue so we better perceive, minus L union R, right? So if we have the probability, right, so this becomes 1 minus probability of L union R, right? That we are okay with. Okay. So that is what we have come up. Okay. So now we are told that the probability of having L is 0.4 and the probability of having R is, as we see there, 0.3, right? 0.4, 0.3. Now, so if we know this to be 0.35, then we can find probability of L union R, and that is 1 minus probability of L complement intersection R complement, and that gives us what? 1 minus 0.35, which is 0.65. We are okay with it. Now, what we are interested in is the probability of having L intersection R that we don't know, right? So we are familiar with this, that L union R is probability of L plus probability of R, right, minus probability of L intersection R. So we can easily find probability of L intersection R from here, which is probability of L plus probability of R, right, minus probability of L union R. Now probability of L is 0.4, probability of R is 0.3, and probability of L union R is 0.65. So we have here 0.7 minus 0.65, and that gives us 0.05. So the probability that we have both events happening, we have lab work done, and the event of referral to a specialist is 0.05, which is our answer choice A. Alright, so that is the answer to our question. Thank you so much for viewing, and we'll hope to see you next time on this channel for more problems to be solved. Thank you.